Hello everyone, this is Mukesh, founder of SeekBytes Private Limited. I'm pleased to share the important feature we have in SeekBytes uh, that is called memory management. So as you can see with screen I have shared, uh, the context is not equal to memory. So a million token context window is not memory. Memory is what survives between the runs. The operational agents that we have, the challenge is deciding what returns, what loses authority, and what is still safe to use. So, if you let me proceed. So, context reset. Memory survives the run. So, when a run begins, short-term memory hold the system prompt, recent history, tool output, and a small retrieved slice. When a run ends, the working context resets. Long-term memory lives outside the call in the form of episodes, facts, skills, and the lessons. The retrieval brings the selected memory back to the system. Write back decide what survives the next run. So these are the loops that we have. We working that decide what to save, forget, or verify is the difficult part or the challenge we face and overcome. So when it comes to SeekBytes, so we turn operational recordings or operational media into governed skill. That got ultimately converted into the SOPs, which can be reviewed, versioned, executed, and supported by the evidence. And later in the automation that happen end to end, we use those SOPs to create end to end automation. The flow is simple: record the work, govern the procedure, and run and prove it with the automation. We are not creating a static transcript or an agent that improvise forever. We want a operational knowledge with the lineage, review, and the audit trail. If the process changes, the system should learn without silently rewriting the policy. Today, I want to show how the memory support that loop and clearly separate the current capability from the next provenance layer. Short-term memory that run a current execution and the long-term memory that survive that execution. So short-term memory is the working context of a execution or run. It contains the system prompt, run history, tool output, retrieved content selected from the current task. It is immediately usable, but it is temporary and bounded. On the other side, the long-term memory that lives outside the window persists between the runs. It holds the episode from previous execution, semantic facts about the environment, and the procedural knowledge in the skill and the lesson. So retrieval moves a small relevant slice into the current window. Write back, which is moves the selected learning in the other direction of the execution or the run. So a bigger database or a million token does not solve the memory problem it's by itself. It is the product decision what crosses between the two lanes or two arrows. So long-term memory is three different jobs. As you can see, we have divided memory management where the long-term memory into the three different categories. You can call it the episodic memory that answer what happens. It preserves the screen, steps, outcome of the skill, run, etc. On the other side, the semantic memory that answers what happened to be true. It holds the fact with scope and the confidence. And the third, we have the procedural memory. How should we act? It contains the skill, lesson, and approved corrections. So keeping these three types separate matters. Episode is the evidence, not automatically a new policy. So a lesson can be proposed a correction, but the governance decides whether it changes the procedure. These type memories let the retrieval choose the right knowledge instead of undifferentiated history. Correct. So now we move to the other side called the write back. So write back is actually the product. In SeekBytes, the write back a governed loop with the 5 stages. First, run create the episodes. So episodes with each execution where there are the screens, steps, evidence, and the outcome. And the second, when the execution fails, the reflector compares what should have happened with what actually happened. It it can turn that failure into the structured lesson and propose the correction. As always, the human reviews remain the default control for promoting those changes or rejecting those changes. Third is the day cycle that accumulate the candidate facts. Fourth, the night cycle that perform the slower consolidation. It group the night cycle and the day cycle that group the related facts, detect conflicts, and refute the stale claims without deleting the audit history. So this prevent an old preferences from the winning forever simply because it is a semantically similar. So finally, the brief stage, select a bounded domain scoped slice for the next run. Every arrow needs a policy. What to observe, what to keep, what to consolidate, and what to retrieve. That governed loop, not merely a database, it is the product in the SeekBytes. So before the next action, the memory passes the two gates. So gate 1 that decide what earn a seat in the context window. The system find active facts, lesson relevant to the skill, then expert briefing and critic distillation compresses that material into small usable context pocket. We do not dump the whole store into the prompt. Confidence decay is very important, and confidence can decay. Facts can be refuted. Domain scope limit where a memory is allowed to travel. The context packet is logged. It connects the run to a skill and selected facts and the lessons and the briefing actually injected. If the agent makes a strange decision, an engineer, a human interference can inspect the context what it really saw instead of just guessing the whole database. So gate 2 we have the agent proof. The memory may say that okay, a button should exist, a URL should be valid, or a procedure should still work. The proof checks the current evidence before the action continues. So in a flow or in an episode, there could be multiple actions, and each action is auditable and get reviewed and get feedback, and it support the separation, which is the essential because the remembered fact can be historically correct and may still be unsafe now. So the rule is simple: memory proposes, proof verifies, and remember is not same as allowed to execute. So only decision changing memory gets the seat. Yeah. So the first production pain is the injection budget. Quality is not how much memory an agent retrieve. It is the smallest set that improves the next decision. So every extra memory competes with the current task. Weakly related facts can bury the instruction that matters. A larger window does not remove that problem. So, would this memory change the next decision? Is the step every time asking a question. So, applying hard limits, domain scope, status filtering, relevance, and the compression we have. The maximum recall look impressive as you know in demos, but bounded, inspected recall, that is the winner in the actual production environment. So formation source must survive the retrieval. So the second production pain is the trust, as the every AI tool that we are building is going through. An operator policy, a verified OCR, and the DOM observation and the LLM inference can all be useful, but they must not carry the same authority. Right? Confidence alone is insufficient. A model can be highly confident and wrong at the same time. So human policy govern, verified observation can challenge the current state, and inference can suggest a hypothesis, but cannot grant itself a authority or a policy. The formation source must therefore survive storage and the retrieval. The inference cannot quietly just supersede the policy. So, meaning to say that the correct then is not safe, is not equal to safe now. The third production pane that we observe, a fact can be correct and still be unsafe to use. That's the reason we have a verifier at each step or each action. So suppose a skill remember a submit button, but today inference shows review and send. It changed the external environment, got changed a button name from submit to review and send. The old memory is plausible. The current action should be blocked, but the current action should be blocked until the system verifies what is present. The retrieval alone cannot solve this problem because the all instruction still may be closest match. Agent proof compare memory and the current evidence. If the inference or the permission change or the agent have seen this behavior in past, so should it proceed? It should gather the proof and then escalate. So memory can be recommended and the current evidence that decide these recommendations. So the next we have the stamp. So each and every fact got formed into the system have a stamp on it. Now we move a roadmap. The next layer is the design and build. So fact rows can look deceptively alike, people such as policy, OCR observation, visual evidence, LM inference may all appear as value plus confidence, right? A confidence guess can then poison the next run. If they have all same confidence. The formation provenance stamp how each fact was created at the right time. And we have that stamping mechanism. So that stamp comes from the code path, not the model description. So a model must never claim as I am a system operator and grant itself a authority. It is the domain specific, and we believe that each domain is different, and we configure a domain in such a way that the authority with the confidence got changed, and these levels are highly plausible to make a difference in each execution when execution is not as per the expectation, then these need to be rewritten. So practical category include the policy, system record, observe evidence, and inferences and generate summary. So formation determines authority, and candidate may still trigger reviews but cannot refute the governed policy before a authorized process changes it. So provenance change which memory wins. So this is the provenance changes which memory wins, not only what they are called. Retrieval can rank it beside the relevance, confidence, freshness, and state and the domain scope. So these equation is conceptual, not a production formula. So each domain have a different formula and can be rewritten whenever it required to upgrade. So policy must not be silently defeated by the inference. Refuted facts may remain for the audit, but should not win the normal retrieval. So domain specific facts should not leak into the unrelated skills. Engineer also need omission reason right into the logging. Uh, so wrong domain refuted or the stale, too stale, below authority, redundant, or the removed by the injection budget. So that makes the memory selection more debuggable instead of just guessing the next execution. So, so with that, memory should improve the next run without just silently authorizing it. Here is the complete picture, the dashboard where we are trying to show how the short-term memory serves a particular run. But this dashboard is not clear. We request you to go our website where we show the multiple dashboards, and this is one of them. So long-term memory preserves the episodes, facts, skills, and the lessons, and the retrieval returns a bounded slice. Write back stores selected learning. Expert briefing control the context packet. Agent proof checks whether the remembered knowledge is still safe. Now, memory is not the size as we have shown you in very first slide. So hope you agree with us now. So it is not the size of the window, it is not the database, it is the governed loop deciding what survives, what returns, and what loses authority over time, and what still required a proof, right? So if you are evaluating a governed skill for SOPs automation, or your agent keep re-injecting the stale preferences, comment memory in the below section or below YouTube video, or book a short demo or walkthrough with us. Sample menu manual is uh, available on the SeekBytes knowledge base at website, so which shows the path for the input recording and the structural workbook. So subscribe to the sales SeekByte, and next I will explain the agent proof versus the memory and why verification remains separate. Yeah, thanks for watching it.